So today's lesson will be on trig ratios. So most of today's lesson is going to be a review of 20-1. The new content that's getting added in is angles in radians instead of degrees, as well as some new ratios, which we're going to learn. So instead of having sine, cosine, and tan, we're going to have another 3 more ratios we have to learn. Now from 20-1, if you remember, if I have an angle in standard position, so that means I start on the positive x-axis and I end my terminal arm at some point xy, I form a reference triangle. On this reference triangle, this is my x-coordinate from here to here. This is my y-coordinate from here to here. And this is my r-coordinate, which we are going to call r, because if you remember, we're going to put a unit circle on top of this. And again, my circle is not going to be drawn really well. But we put a circle on top, and this circle usually has a radius of r. Okay, so that's why we'll use the variable r. And again, if you recall, this is an equation of a circle in... This is the equation of a circle with center at 0, 0, and radius of r. Now, if I'm on the unit circle, my radius would be 1. And once we know the values of x, y, and r, if this is my theta on the triangle, my sine, cosine, and tan can be defined using your SOHCAHTOA in terms of x, y, and r. So my sine of theta would be my y over my r. My cosine of theta is adjacent over hypotenuse, so opposite adjacent over hypotenuse would be x over r. The y kind of got deleted from there. And my tan of theta would be my opposite over my adjacent, which would be y over x. And now this part is new. We're going to define some reciprocal ratios. And now with the reciprocal ratios, we know that C is cosecant and S is sine. And when I put these trig ratios together, you have to remember a C goes with an S. So sometimes people can't remember whether cosecant goes with sine or cosine. Cosecant can't go with cosine because you would have two C's and you need to have a C and an S. But the nice thing is this column is on your formula sheet, and it reminds you about which one goes with what. So my cosecant is my reciprocal of sine, so therefore if I take the reciprocal of y over r, I get r over y. When I do my secant ratio, this word is new to you, secant. Secant gives you no hints that this is related to cosine, but I remember that an S goes with a C. The reciprocal of cosine is r over x. And then my cotan is the reciprocal of tan. So when you see the word cotangent, you can kind of see the word tan in there. And the reciprocal of tan is x over y. So these are my 6 ratios. This material and this material is not on your formula sheet, so those are things you have to remember based on the triangle you draw. Also from 20-1, you had to have remembered the cast rule. And what the cast rule tells you is which ratios are positive in which quadrants. So this is telling me all ratios are positive. This one is telling me that only the sine ratio is positive. But because cosecant is the reciprocal of sine, cosecant would also be positive. But that's sort of a secondary step. As long as you know sine is positive, when you do the reciprocal for cosecant, you'll also know that it's positive. This quadrant has a t in it, so I know that tangent is positive. And then in this quadrant, cosine is positive. So the word cast, if you remember, comes from the first letter of each of these words to give you the C-A-S-T. Another thing you have to remember is this is considered quadrant 1, quadrant 2, quadrant 3, and quadrant 4, we move in a counterclockwise direction for positive angles, and we move in a clockwise direction for negative angles. But quadrant 1, 2, 3, 4 gets labeled from top right in a counterclockwise direction. Now, these first few examples we do are going to be a repeat of 20-1. The only new aspect to the problem is I'm giving you information in radians. So pi, hopefully you remember pi is half of 2 pi, and 2 pi would be 360 degrees, so pi would be 180 degrees, and then 2 pi would be 360 degrees. Some of your brains will work better in degrees than they will in radians. So right now, I know that I have an angle that's between 180 and 360 degrees, moving in a counterclockwise direction. But I also have a clue because in here, they're not giving me a sign for cosine. So I'm assuming that the sign is going to be a positive. So for cosine, C-A-S-T, cosine would be positive in quadrant 4 and in quadrant 1. But because of this kind of restriction here, I know I have to have my angle in quadrant 4. So all those clues tell me that my rotational angle is located somewhere in quadrant 4 with a value of theta. Now I draw my reference triangle. My x value is 1, my r value is 2, so this is going to be a 1. My r value is going to be a 2. I need to solve for my y variable. So I'm going to use Pythagorean theorem because this is a 90-degree angle. 2 squared is equal to 1 squared plus x squared. 4 is equal to 1 plus x squared. X squared is equal to 3, and then I want to solve for x. So when I square root both sides, I need to remember to do plus or minus. Now you'll notice over here that this distance is kind of in quadrant 4, and I know on an axis that y would represent a negative value. So, and oops, I used the wrong variable here. I want this to be y, not x. So my y is root plus or minus root 3, but specifically in quadrant 4, my y would be the negative root 3. So I'm going to come back and put that in as negative root 3. Now they say find the ratio for sine. So sine of my purple angle theta would be my y over r, which is negative root 3 over 2. And when I put the signs on the triangle, I've already taken care of the cast rule because I know in quadrant 4, sine would be negative. In quadrant 4, I also know tan will be negative. But if I do the values on my triangle, which is y over x, I get negative root 3 over 1. So the fact that I already put a negative sign here means I've already taken care of the cast rule, and I don't have to double count it. Like I don't have to say that tan is negative and put another negative sign, because then all of a sudden I would get a positive value. Okay, let's look at the next example. Cosecant is the reciprocal of sine of theta, and I know that sine of theta is y over r. So this would be my r value, and this would be my y value, and this negative is going to get attached with the y value because my r is always positive. So I'm going to come draw my triangle. I need to have some clues about what quadrant I'm going to be in. So I have a negative pi over 2 to positive pi over 2. So this would be negative 90 degrees and positive 90 degrees. You need to recognize pi over 2 right away as 90 degrees, positive and negative. So that means if I go in the positive direction, I would be somewhere in quadrant 1 if I was between 0 and 90. And then if I'm between minus 90 and 0, I would be somewhere in quadrant 4. Now, more clues. The cosecant is negative, which means my sine is negative, which when I draw my cast rule out, I have to be sitting in quadrant 4 because quadrant 1, sine would be positive. So I'm going to draw my diagram in quadrant 4. So my rotational angle is in quadrant 4. When I draw my reference triangle, it gets put up to the x-axis. My y-coordinate is -7, and my x-coordinate is 4. So as soon as I put a negative on a triangle, I've already taken care of my cast rule. So let's find our x-coordinate. X squared plus √7 squared equals 4 squared. You can just consider all of these values positive. X squared plus 7 is equal to 16. Move the 7 over by subtracting 7 on both sides. Square root both sides, and I get the square root of 9, which is plus or minus 3. Now, because I'm moving in the positive x direction, I'm going to use my 3, and I'm going to state that my x is only equal to +3 because I'm moving in the positive direction. So my primary trig ratios, sine of my purple angle theta is y over r. Whoops, my r is the 4. My cosine of theta is my x over r. And my tan of theta is y over x. Okay. Now the next example, let's take a look at it. This time around, I'm going from an angle between minus pi and pi. So minus pi is all of this stuff, and positive pi is all of this stuff. So I'm actually in all 4 quadrants right now. So that doesn't give me any clues. Then it tells me tan is negative. So tan would be negative in quadrant C and quadrant S, which is quadrant 2 and 4. But because they give me no other clues, I'm going to have 2 possible answers. So I would want to draw a quadrant 2 angle and a quadrant 4 angle because I'm going to have 2 possible answers for this angle. So I'm going to draw my triangle in quadrant 2. And then I'm going to draw my triangle in quadrant 4. And in both scenarios, my rotational angle goes from the positive x-axis to the terminal arm. Now tan is y over x. So in quadrant 2, my y is positive, so I'm going to put the positive with the √3. And my x is negative, so I'm going to put the 5 with the negative sign. But in quadrant 4, my y is negative and my x is positive. So it's kind of telling you what happens if the negative is with the √3 versus the negative with the 5. And you're going to get 2 possible answers. Now in both scenarios, 5 squared plus √3 squared is equal to r squared. You don't need to take into consideration the signs because the reference triangles have only positives on their triangle. The negative refers to the direction you're in or the quadrant you're in. 25 plus √3 squared is 3 equals r squared. R squared is equal to 28, so r is only positive because r is greater than 0, √28. Now from 20-1, you need to break up the 28 into 2 numbers where one is a perfect square. So this simplification would be the square root of 4 is 2, and then I'd have a 7 left over under my radical. So in both triangles, my r value is positive and 2 over √7. Now the goal is to find the 3 reciprocal ratios. So secant theta is the reciprocal of cosine, so that would be r over x. My cosecant of theta would be my reciprocal of sine, which is r over y, and then my cotan of theta would be my y over x, but the reciprocal, which is x over y. Okay, so secant of my triangle would be my r value, divide by my x. My cosecant would be r divided by y, and then my cotan would be the x divided by the y. And so those are my 3 ratios in exact form. It is always expected that these answers are given exact form. In this triangle, my x is 5. Oops, so I need to do my r divided by my x. So 2 root 7 divided by 5. This time the 5 is positive, where in quadrant 2 the 5 was negative. My cosecant of theta would be 2 root 7 divided by my y-coordinate, which would be negative root 3 this time. And my cotan of theta would be the 5x over y, and negative root 5 over negative root 3. Now this again is a repeat of 20-1. Now what we're going to try to move into is reading the trig ratios on the unit circle. So what we know about the unit circle is I put this blue circle around my angle in standard position, and then I know when I do my terminal arm, the distance from the origin to any outer part of the circle is 1, because my radius on a unit circle is 1. And if I know my radius is equal to 1, then my cosine value is going to be x, because r would be 1. My sine of theta would also equal y, because y over 1 is just y. So any point on the unit circle would be my cosine of theta, which is like my x-coordinate. And then my y-coordinate would be sine of theta. And we've talked about this on Friday when we do our hand trick, or when we put the values on the unit circles in the bracket. Each bracket that we write, the first coordinate represents cosine and the second coordinate represents sine. Now, if I have cosine theta equals x over r and sine theta equals y over r, just those ratios, opposite over hypotenuse for sine, adjacent over hypotenuse for cosine. If I'm just writing my normal x, y coordinates, then this would be x over r and y over r. So you can think of it either as cos of theta, sine of theta, or x over r, y over r. Okay, so that's just like my normal ordered pair. Okay. And we also know that tan is y over x, or you can take tan, which is y, which is sine theta, and my x, which is cosine theta, and again, that's a relationship we know for tan, and this relationship for tan is on your formula sheet to help you remember. Now find the exact value, so no decimals, no calculators, no decimals to try to help you, for the following angles. We want the ratios, so we want sine, cosine, and tan. And then they don't really necessarily tell us, but in the question they say we only want the primary ratios, which are the sine, cosine, and tan. So sine theta, cosine theta, and tan theta. So now we're not really drawing a triangle at all. What we want to know is, okay, 150 degrees sits in quadrant 2. So if I want to know how much more I need to get to 180, that would represent my reference angle, which in this case is 30 degrees. So basically the sine and cosine and tan of 30 degrees would play a role into the sine, cosine, and tan of 150, or you look on your unit circle and figure out what this value is. Now I'm going to use my hand trick. So what we're going to do when we do our hand trick is we put our right hand in front of us, imaginary square root like we've talked about. You're going to locate your 30-degree finger. So 0, 30. So you're going to bend that finger down. And your fingers get divided into 2 sections. So the cosine side is 1, 2, 3 fingers. So cosine of 30 degrees is root 3 divided by 2. My sine gets divided into 1 finger, so sine of 30 is root 1 divided by 2, which is just the same thing as 1 over 2. And my tan of 30, remember, is my sine fingers, which was the root 1, divided by my cosine fingers, which is the root 3. And then that cleans up to 1 over root 3. But that only is an intermediate step to get to my answer. If I want to get cos of 150 degrees, The only thing I have to do is add on my cast rule. So I'm going to say plus cast rule. Now my actual angle is in quadrant 2. So when I put my cast rule down, C-A-S-T, only sign should be positive. So this one is negative. Tan of 150 would also be negative. And my sine of 150 degrees would be positive. So my fingers only give me the actual values, and to get the actual signs, I need to use cast rule. So cosine is going to stay exactly the same, tan is going to stay exactly the same, and sine is going to stay exactly the same, but we have to add the values of their signs, which are positive or negatives, based on the quadrant number. Okay? So this set of values would represent my final answer. Now 3 pi over 2, this one doesn't really form a nice reference triangle at all. I know when I look at this angle, I'm kind of highlighting the base angle, which is 90 degrees, and I do 3 multiples of 90. So 0 to 90 is 1, 180 is 2, 270 is 3 multiples of 90. And it's sort of hard to form a reference triangle, but if I'm looking at the ordered pair that sits right here on the unit circle, my x-coordinate is 0, but I've gone a distance of -1 for the y-coordinate because I'm sitting on the edge of the unit circle. Okay, so now I'm going to do my sine of theta is my y-coordinate, which is -1. My cosine of theta is my x-coordinate, which is 0. And my tan of theta is going to be my y divided by my x, which means that my tangent ratio is undefined. And all of these thetas are 3 pi over 2. When I do the cosecant of theta, this is the reciprocal of sine, 1 over -1, which gives me -1. My secant of theta is 1 over 0. I can't divide by 0. That's a problem, so we say that the secant value is undefined. And then my cotan value, I'm going to do the reciprocal, 0 divided by -1, and 0 divided by -1 is 0. So sometimes these angles can cause values that are really funny or undefined if you're dividing by a 0. Okay, this time I only want my reciprocal ratios. I identify my base angle, which is giving me my reference. My theta reference, in this case, is pi over 4. I have 3 multiples of pi over 4, which is kind of why this 3 is out here. I have 3 multiples of 45, so I'm at 135. And then I need to move in a clockwise direction because that's negative. So 0, 45, 90, 135, moved in the negative direction, which is -3 pi over 4. Now they gave me the angle in radians, so I want my answers to work out where I represent my angle in radians, my reciprocal trig ratio. So cotan, -3 pi over 4. My, I'm trying to write my trig ratios. My secant of -3 pi over 4, and my cosecant of theta, and I should put my theta in, which is -3 pi over 4. So we have to remember that cotan is x over y, secant is x over r, so the reciprocal of x over r is r over x. Cosecant matches with sine, so the reciprocal of sine is y, r over y. Now, I don't know these coordinates. You can draw a reference triangle and remember them. That could be your special triangle. You can memorize the unit circle and write down the ordered pair that came right at -3 pi over 4. Or I can use my theta reference off my fingers. Okay, my theta reference is 45 degrees, which is that base angle. I put down my 45-degree angle, or my 45-degree finger, which is my middle one. Now I'm going to kind of put the cast rule in. So this is C-A-S-T. So cotan will be positive because it's the reciprocal of tan. Secant and cosecant will both be negative because they're the reciprocals of sine and cosine. And sine and cosine are negative in quadrant 3. Now I'm just going to take the values off my fingers. So I have 2 cosine fingers. My palm is a 2. So my secant would be 2 over root 2. I go in the reverse direction. I read the palm and then the fingers. My sine is root 2 over 2. So my cosecant would be the reverse or the reciprocal of it, 2 over root 2. And then my cotan would be the cosine fingers divided by the sine fingers because it's in reverse. Root 2 divided by root 2, which is a positive 1. Okay. Let's look at the next example. So now when I look at this, they tell me that this point sits on the unit circle, but I don't really recognize these off my fingers at all, right? I don't know what my reference angle is. I'm not sure. So what I'm going to do is I'm going to draw my point, which has a negative x coordinate, so I'm moving to the left, and then a positive y coordinate, which means I'm moving up, and there's my point. I draw my reference triangle. Here's my rotational angle theta. So this x coordinate is negative 1/3 because they label that for me. My y coordinate is 2 root 2 divided by 3. They label that for me. I need to find my r coordinate, but I know because I sit on the unit circle, my r is just 1. And you could verify that, but I don't really want to do that step. But you could verify that x squared plus y squared when you work it out gives you a 1. And we want to find all the primary trig ratios. So sine of theta is my y over r, so 2 root 2 over 3, and then my r is 1. My cosine of theta is my x over r, but my r is 1, so it's just negative 1 over 3. And then my tan of theta is my y over x, which is 2 root 2 divided by 3 divided by negative 1/3. You do have to simplify that by hand because you don't have a choice. 2 root 2 divided by 3 times the reciprocal of the denominator, negative 3 over 1. That's how you divide fractions. These cancel out. And now we're left with negative 2 root 2 divided by 1, which is just negative 2 root 2. Find the exact value of sine 2 pi over 3 minus tan of pi over 4. Again, we want no decimals, so you should not be even picking up your calculator. We need to identify the reference angle of both. So you have to draw the angles out and then visualize the reference, or you can kind of try to find out what your base angle is if it is something off your unit circle. So I've highlighted my base angle in both. I have a pi over 3 on the left angle, and I have a pi over 4 on the right angle. Now, sine of 2 pi over 3 tells me I have 2 multiples of pi over 3, and pi over 3 is a 60 degrees. So this means I'm in quadrant 2 here. So quadrant 2. And pi over 4 means I have 1 multiple of pi over 4, which is 45 degrees, which means I'm in quadrant 1. What I'm going to do is I'm going to draw my fingers out to help me remember what is the sine of pi over 3. So pi over 3 is 60, so 0, 30, 45, 60. I put my 60 finger down, and then because I'm only asked for the sine, I'm only going to read off my sine fingers. 1, 2, 3. So root 3 divided by 2, my palm. And then in quadrant 2, sign is positive. In quadrant 1, I'm doing tan of pi over 4. So my right hand in front of me, there's an imaginary 2. I'm going to put down my pi over 4 finger. 0, 30, 45 finger goes down. My fingers get divided into 2 sections. I'm looking for the tan of pi over 4, so I'm going to read my sign fingers. Root 2. Divide by my cosine fingers. Root 2. And then I know because I'm in quadrant 1, my tan is positive. Moreover, all of them are positive, but my tan is positive. Now this one simplifies to a 1. So now they're asking me to find the exact value of sine 2 pi over 3 minus tan of pi over 4. So sine of 2 pi over 3 was root 3 over 2 minus tan of pi over 4 was 1. Now, sometimes it's expected you clean this up into a common denominator, so I'm going to multiply this fraction by 2 over 2. And then my final answer is root 3. 2 times 1 is 2. Root 3 minus 2 over 2. And that would be my final answer. Now we're going to stop our lesson there and continue with this in tomorrow's class.